Hey everybody, welcome to the introductory lecture for mobile computing, which is COMS 2013A and COMS 2019A. My name is Pravesh Ranchar and I'm the lecturer for this course. You can see my email address up there, pravesh.ranchar@wits.ac.za. Don't hesitate to use it, but you will get better response if you use Discord. For those of you who've never used Discord before, Discord is something similar to WhatsApp. It's a chat program you can run on your phone or on your computer. And you can just chat in real time. It allows voice chat and video chat as well. But one of the cool things about it and why we've used it extensively is that you can actually structure chats a lot more effectively than on WhatsApp. So this will be the primary method of communication in the course. And so I'd encourage you to install it on your phone and computer and all other relevant devices. And hopefully we'll have a lot of fun in those groups. Now, you've already signed up to do the course, so I guess I don't really have to convince you. But what is mobile computing and why are you doing it? Well, the course is just a course on making apps using Java and SQL. So a lot of this course will overlap with database fundamentals or work in conjunction with database fundamentals. In that when you're making apps, you generally want to make database-driven apps, okay? What that means is your apps need some way of storing data and managing data, and database fundamentals will teach you that part, and this course will teach you the part about how to make apps. Now, the question is why? Well, hopefully I don't really have to answer that one because, well, you'll be making apps, right? That's pretty cool. But the main reason this course was introduced is to teach programming in Java. Now, at some point, this course was a pure Java programming course, and we decided to use Android instead just because it's more fun. Why does that matter? Well, it matters because funner programs make you program more. And programming more makes you good at programming. So from second years who've seen programming in first year, the most common question I get is, well, how do I get good at programming? I'm really struggling with programming. And programming is a bit like soccer. Right? You can watch YouTube videos on how to play soccer. You can read books on how to play soccer. You can read instruction manuals and listen to advice. And all of that will help. But what will really make you good at soccer is playing soccer. Similarly with programming, you're not going to get good at programming unless you program, right? So a fundamental goal of what we're doing in this course is to make you enjoy programming so that you'll just do it for fun. Okay, if you do it for fun and you give yourself some projects that you think are cool and you work on those projects, you're going to get good at programming. Okay, so the main reasons are up there, but there are some rather more important reasons that I think don't get enough attention, and one of them is to show off. I think this is a heavily underestimated part of why we do stuff. It's to show off, right? Like one of the best things about making something cool is that you get to show other people that you made something cool, and they go, "Damn, you are smart," and you're like, "Yeah, I kind of am. And the other reason is to solve real problems, right? So apps have a very low barrier to entry, and what that's really useful for is for solving problems that you've observed in the real world. Okay, so you've seen some problem and now you have an avenue to solve it. I'm going to come back to the soccer example. I always had this problem where when you'd play five-a-side soccer, the teams would end up really unbalanced. And one of the groups in previous years built an app that would rebalance teams so that they'd become more competitive, which makes the game a lot more fun. Right? So the cool thing about app development is that you can just do that. There's no barrier. You can just make an app that solves a problem. Okay, so the course is inspired by something called the SOUL methodology, and I want to talk to you about it a little bit. I know teaching philosophy is probably not something that's at all interesting to you, but I want to talk to you a little bit so that you can at least understand what I'm doing. Some of the time, when you're thinking your lecturer is being mean or your lecturer is being lazy or your lecturer is being incompetent, it's actually that your lecturer hasn't really explained what it is they're trying to achieve. Okay, so hopefully by outlining my teaching philosophy, I can make that less of a problem in this course. So, according to this idea of the soul idea, there's 4 things you need to learn. Okay? One thing that you need is access to content. And that kind of makes sense. If you're trying to learn how to do X, but there's no content available on how to do X, you're going to struggle to do that, right? You're going to have to learn everything from first principles. Now, importantly, access to content doesn't mean that someone needs to give you the content. It just means that you need to have the ability to get the content. Okay? Another item that you need is concrete goals. Okay, so as an example, let's say I said that we're going to learn how to use Android's GPS. Maybe I'll give you some commands, say here's how you get the position, here's how you store it, you can do stuff with this location, and if you type this code, it'll refresh the location every 5 seconds or something like that. You'll listen to it, you'll nod along, and then you'll just throw it away because you don't care, right? The only time you're going to care about how to do something is when you need to do something, right? When you have a goal that requires it. So for instance, if I told you that you actually need to develop a track and trace app for COVID so that you can tell whether in the last 7 days you came into contact with someone with COVID. And to do that, you're going to need everyone's GPS location. Then you'll just automatically learn how to get the GPS location, right? You'll look it up, you'll implement it, you'll get it all done because you care. Because there's something in there that you actually want to achieve, okay? So that's quite an important component of learning. Another important component is friends. So you'll find that friends are useful for a number of reasons. One is that they're good motivation. Often if your friends are interested in something, then you'll be more interested in it than you would be in other things, okay? So if you find that your friends are into graphic design, you may find that suddenly you're interested in graphic design or interested in some things that make use of graphic design, because that way you get to work on things with your friends, which is always fun. Another reason is that friends are what's called a force multiplier. What that means is that the amount of energy you put into discovering something is summed up, right? You get the additive sum of all the energy. So if your friend learns how to do a cool animation on Android, then you'll automatically learn it because your friend will tell you, okay? If they don't tell you, you've got the wrong sorts of friends. But learning is fundamentally a social endeavor. Very few things are learned in isolation, right? Mostly we talk to our friends, we talk to our peers, we talk to our lecturers, we talk to our tutors, and we learn from people, okay? So fundamentally you need people. And the 4th thing you need is positive feedback. So remember earlier I was talking about we want to show off. And that's important. Like you want to be acknowledged for the things that you do, right? You want people to look at the things you do and go, oh my word, that is amazing. And for them to do that, you have to make amazing things, of course. But when you make something amazing, it's really important that what you get is feedback that this thing is amazing, okay? And if you've got these 4 things, you'll do pretty well. There's a very interesting piece of research by the guy who developed the SOUL methodology about positive feedback, and this really blew my mind. He was testing this on kids in rural India that were learning to use computers, and in testing the positive feedback part of the theory, he enlisted some grandmothers as research assistants. And what he told the grandmothers to do, this is fascinating, he told them that whatever the kids were doing on the computer, without even bothering to check what it was they were doing, they should just be like, whoa, that's amazing. How did you even do that? That's really cool. And what he found was that in the groups that received this positive feedback, even though it was linked to nothing, the groups did much better than groups without positive feedback. And I think this makes sense simply because I think one of the biggest reasons that people will fail at anything is because they've defined themselves as not good at it, right? Now, I know some of you will have struggled with programming before. I know I myself have struggled with programming in the past. And it's very hard not to define yourself as someone who struggles with programming, or someone who struggles with math, or someone who struggles with, anything that you're not particularly good at. And it's important to recognize that, you're not. That's not a definition of you. You're going to get good at this. That's why you're in the course, right? You wouldn't be in the course if you're already amazing at everything. You'd just be out there being amazing. So positive feedback is an important part of the process. But what I found really interesting when I looked at this, so this was something that was developed for early education, so meant to be for children. But what was interesting to me was that, all of these are quite plausible, right? Like, it's easy to see why all of these are necessary to learn. But what was amazing to me is that this is not something universities do, right? So let's look at these 4 pillars. One is access to content. Now, importantly, access to content also means the ability to access that content, right? So it's not just that content is available to you, it's that you have the ability to find that content and sort of sift through various bits of content to find the appropriate content, okay? And universities do this quite well at postgraduate level, but in undergrad, a lot of the time, what courses will do is they'll give you the content. They'll give you a book that defines the syllabus, or they'll give you a set of material that defines the syllabus. And what that trains you to do is learn only from that syllabus, okay? So you don't have the ability then to just independently find content. And I've been here a long time, so I can sort of give you an idea of what it is that has made superstars, right? So to give you some examples, Steve, Ritesh, Richard, all of whom lectured you, were in my classes at some point. And the powerful thing that stood out about them was that they never waited for the lecturer to tell them something. If they wanted to know something, they just went and found out. They just accessed content themselves, okay? And this was just sort of something that they had in them. But I feel that it's important that we train that a little bit. So you'll find a lot of the time in the course, I might give you some pointers on where to find some content, but I won't give you the content and I won't direct you to exactly where the content is, okay? And that's because this is part of your training. You've got to get used to the fact that the entire internet is there for you and you're going to have to go and find some stuff. Okay. Another thing we often do wrong is concrete goals. Okay, so who here is inspired by writing a for loop? I assume nobody. And yet when we teach it, what we do is we say, here's how you write a for loop. We don't give you a goal that says, you need to do something that you actually care about, and then in doing so you have to write a for loop. No, what we do is we go, here's the syntax for a for loop, and sum up all these numbers that you don't care about summing up. And then when you write that program, you learn how to sum up numbers. There is some of that in this course, I will admit, and I'm not proud of it, but it is there. But most of the time, what we'll do is give you exercises that feel real, okay? And the assignment comes in here to a large degree in terms of what we're trying to do is give you something real that you could actually deploy and that people might actually want to download and use. And in building that app, you'll learn all the things that the course is supposed to teach you. Okay, so the concrete goals are there to sort of push your learning, but the only time you'll actually do that learning is because you have those concrete goals. Okay, friends, this is something universities unintentionally do well, in that universities are some of the best places to meet cool people who are smart and like the same things you like. So universities do a good job there, but what we do a bad job of is of having you make use of your friends, right? So we'll often be so worried about testing that we will sort of say, don't work with your friends, or don't talk to your friends about the assignment, or, don't get pointers from your friends because we want this to be your own work. The reality is very little in life is your own work. Almost everything is influenced by the friends you have and the stuff that you do with them. So I would like to encourage you that you want to help people and you want to get help from people. Again, learning is a fundamentally social thing. So it's not helpful to cocoon yourself. What you want to do is say, hey guys, I don't really know how to do this thing. Anyone have some ideas, and just chat it out, right? What you shouldn't do is just copy someone's code, because that's not social learning, right? The social part of social learning is important, but the learning part of social learning is pretty important as well. And copying someone's code wouldn't help you learn at all. But being social is tremendously important. That's how you learn most things, and that's how you can stay motivated about most things. So in the course, a lot of the work you'll be doing will be done in pairs or groups. And I will expect discussion from you guys. I'll expect feedback. I'll expect all sorts of things coming from that peer group. Okay. The fourth one, positive feedback. So this is something that we don't do particularly well in higher education as well, in that what we mostly try to give you is threat, right? So like, do this work or you're going to fail. Do this work or we'll have to expel you. Do this work or else. And I think what's often missing here is, do this work because it's awesome. Do this work because you're going to be amazing when you know how to do all this work, right? Do this work because it's something fun to do. Okay, so in the course, hopefully we'll give you a lot of positive feedback, because the stuff you'll be doing will be awesome. Okay, so on that note, feedback is also important in terms of you giving feedback to me. So don't hesitate to tell me that, hey, that exercise you gave us was incredibly dull and we never want to see it again. I like to hear that sort of thing, because it means you're thinking about these exercises and that next year's course will be better and just always on an upward trajectory. On a more concrete level, what do we actually do in this course? Well, the main thing we do is Java. The purpose of this course is to teach you Java. Java is pretty similar to C++, so we don't take a long time covering the concepts, right? I think we'll spend something like 2 lectures talking about how Java works, maybe 3. Simply because you've done C++ and it's fine, right? You're not going to get better at it from me talking at you. You're going to get better at it from coding. So you're going to get a ton of Java exercises to program with, but you're not actually I'm not going to talk to you about Java that much. One big difference that we're going to talk about in terms of Java versus C++ versus Python is compilation versus interpretation. So I guess you all know C++ is a compiled language. You use GCC to compile it, whereas Python was an interpreted language and you use the Python interpreter to interpret it. Java is sort of halfway. Java is compiled and interpreted. It uses a virtual machine. So what happens with Java is your code gets compiled to bytecode, which is a sort of intermediate language, and then when you run it, it gets interpreted. Okay, so this is kind of weird. But if you think of an analogy to real languages, compiled is like, let's say you wanted to translate a book, and the book was written in French, and you want to translate it to English. Compilation says, okay, take the entire book, transcribe it to English, and leave the book there for the next person. Okay, so you've just done a translation up front. Interpretation says, as you're reading the book, read it in French, like in your head, but then say it in English. So translate it on the fly. Okay, what Java does is it says, maybe translate the book from French to German up front. So you got a German book, and then read the German book in English, if you know what I mean. So interpret it on the fly. So you sort of have this combination of compilation and interpretation. We'll also talk a bit about object orientation. I think you did some of that in first year in C++ with Richard, probably. We'll talk a little bit more about some language features that help with object orientation and why it's useful there. Okay, the sort of cheat version is that it's useful because it lets us reuse code. And why do we care about reusing code? Because we're lazy. Well, I certainly am anyway. Certainly, I have a lot of fun writing code. I really enjoy writing code. But you know what's better than writing code? Not writing code. And by that I mean, if I can achieve the same outcome by not writing code, I'd rather do that, right? Because I'm lazy. So object orientation is one of those tools that allows us to achieve outcomes by writing less code. Okay, this being an app development course, we'll cover some concepts in UI design, that's user interface design and implementation. So how do we actually get those user interface designs onto the screen? We'll cover database integration. Remember, we said this course runs in parallel with database fundamentals for a reason. And that reason is that these apps need to be data-driven. To that end, we'll also cover web services, and we'll talk about security in these web services and how we interact with databases from these web services. I find the security parts are quite popular because when we're talking about how to close security holes, it's necessary to talk about what the security holes are in the first place. And I found that mostly students really like this stuff. So a bit of an open secret, I used to be quite a hacker myself. I used to break into lots and lots of servers. I don't I don't do that anymore. But I wouldn't be surprised if some of you do. And I will be discussing some security holes, some common things that make your apps insecure. And of course, the reason I'm doing it is so that you can not do those things, right? So that you can make sure that your apps are secure. Okay, so what I need from you. So this course, I talked a lot about the reason we do it being that it's fun, right? So this course is about having fun programming. So I expect you to have fun programming, right? Do some cool projects, do things that you really like doing, and make cool stuff. Another thing I expect of you is tell me what's working and what's not working in the course. Feedback from previous students has informed the direction of the course that you're going to experience, and hopefully for next year it'll be even better as you tell me the things that I'm screwing up on this year. So in Discord, there is a channel that allows you to give comments and suggestions to me on my lecturing, and I'd love to hear them. The other thing I need from you is please do this the easy way, right? So I always give people the speech that good computer scientists are lazy, but I think this is often misunderstood, right? Is doing your labs energetic? Is not doing it lazy? Well, I am an incredibly lazy guy, but I did all my labs. One very important reason is because they were fun, but another important reason is because, well, what's lazier? Doing computer science once or doing it twice? I mean, doing it once is just way easier, right? So if you're trying to sort of minimize your effort, it's very important to make sure that you pass. And the cool thing is there's a cheat code to pass computer science too. And that's do your labs, right? I've never heard of anyone who did their labs and then failed. It just doesn't happen. If you do all your labs, you will pass. It's very tempting at times to say, you know what, I've got a ton of work in all my courses, and so I'm just going to copy this lab from my friend. Not all the labs, just this lab. But then, of course, this lab leads into the next lab. So on the next lab, you have no choice but to copy from your friend because you didn't learn the lesson from the previous lab. And that way is a disaster. That's not the easy way. Okay. And even if you find good ways to cheat, the problem with finding good ways to cheat is that you're obligated to do them forever, right? So you're intending to become a computer scientist. So if you don't get good at programming, you're going to have to find good ways to pretend to be good at programming. And you're going to have to do this on a continuous basis for the rest of your life. I mean, that sounds pretty exhausting to me, even just saying it, right? Anything you got to do for the rest of your life like that just sounds hard. You're going to have to keep coming up with ways to like avoid programming or get other people to do your programming for you. Or, I mean, that's too much work. It's way easier to just learn to program. Okay, so do this the easy way. Okay, so what's next? Well, the first thing is you need to install some things. Okay, there's a lot of software that's necessary in this course. The most pressing ones are Java and Eclipse because you're going to start off programming in Java. We're not going to start immediately with Android. We're going to start with just plain Java. So for that, you need to install Eclipse and Java. If you're comfortable using something like Visual Studio Code or IntelliJ, go for it. But bear in mind that the exercises are all developed with Eclipse in mind. So it's often easier to just, take that path of least resistance. Another thing you want to install is Android Studio with the optional offline pack. So Android Studio is huge, and when it's running, it actually downloads a ton of stuff when you compile your programs and stuff. If you get the offline pack, all of that stuff's included, but it, like I say, it is huge. But otherwise, if data is not a problem, you can always just not download the offline pack, and as you're using Android Studio, it will download things. Another thing you can install, but you by no means have to, is something called XAMPP, which allows your computer to function as a web server. So when we do the web services part, you can just work on your own machine instead of working on a remote web server. And the final one is something called the Android Alternative, which is something I've developed, which is sort of very similar to Android, but doesn't require Android Studio. So this is a way of making web applications, which are very similar to apps. And but instead of running on a mobile device, they run in your web browser. I developed this mostly because Android Studio is a bit of a resource hog, and the Android emulator is even more so. So when you're testing your apps, you have to run an emulator for a phone so that you can run your apps on that emulated phone, right? The Android Alternative instead generates a web application, which means you just run it in Chrome or Firefox, and it runs fine. So it uses a lot less resources. So if you're struggling to run Android Studio because your computer doesn't have enough RAM or the processor is too slow, then try out the Android Alternative. I'd suggest at this point install the Android Alternative anyway, because we will do at least one lab on it, and you can choose to do other labs on it if you find that Android Studio is too slow. Okay, so the course structure, there'll be lectures every Friday. I know I'm uploading this one on a Wednesday, but in general, lectures will be every Friday, and labs will be on Wednesday and Thursday. The tutorials and labs will be mixed, so there'll be tutorials and labs for mobile computing, and they'll be concurrent with database fundamentals. That means every Wednesday and Thursday, you may or may not get a lab for database fundamentals or mobile computing. And it's kind of unpredictable. So you might get a lab for both mobile computing and database fundamentals one week, and then nothing for the two of them the next week. But your tutors will be available in both of those sessions, and you just got to roll with the punches. If you get, whatever you get for mobile computing, you got to do it. Whatever you get for database fundamentals, you got to do it. The mark breakdown is there on the slides, but I just want to highlight the assignment, because the assignment is the really fun part of the course. The assignment is done in groups, and you produce apps. In the past, students have produced amazing apps. I mean, just really top-notch stuff, like stuff where I would not hesitate to call that a commercial product. And that's one of the cool things about this course, is that what it does is that hopefully by the end of the course, you would feel comfortable releasing your apps into the market. You are a professional software developer by the end of this course, which is really cool, right? It means you can think of an idea, take it through all the way to completion, and commercialize it. And, you can sell your services to people who want apps. You're a fully valid software developer in that sense. So as an example, we had students who built restaurant delivery system apps. We had students who built the one I talked about balancing five-a-side soccer teams. We had ones who designed an artisan app. So you could, let's say you needed a plumber, you could search for a plumber, and then you could rate all the plumbers, and you could see how your friends rated particular plumbers, and you could call the plumber and engage the plumber. We had apps where people built stuff around course management. So, like forums where students could talk to each other and upvote each other and things like that. We had things where you could trade resources, like if you had a textbook someone else needed and they had, I don't know, shoes you needed. I just made that up. But you could trade things in the app. So people have been building lots of cool things, and I hope you guys will do that as well. We tend to run this by giving you some predefined topics, which Hima and myself have come up with, and then saying, look, if you've got a better idea, tell us about the idea, and we'd love you to work on that. We do find that students who come up with their own ideas tend to do better simply because their ideas they care about more, right? So if you're thinking of sinking tons of hours into something, and you're going to sink tons of hours into the assignment, it's not going to be easy. It's better if you sink them into something you really want to accomplish than something that I really want to accomplish. So, give it some thought. What sort of apps would you like to build, and, discuss them with us. And if they meet the requirements, we would be more than happy for you to do them. Okay, and that's that. That's everything I wanted to talk about in the introductory lecture. I hope that it seems like it's going to be intriguing and fun. We will do a ton of class discussion in this course, and it remains to be seen how well it's going to work in the non-face-to-face mode. But I think it's going to be good. I think it's going to be a lot of fun, and I'm really looking forward to it. So I hope you are as well. Thank you for listening to me. Bye.